Yeah.
Yeah. What's your thing?
And then I'm gonna retire.
Yeah. What's your thingy name?
Just Kelly Knowles.
Yeah.
Just Kelly Knowles.
How many subscribers?
My channel. It goes through my Gmail account. So. All right.
The more likes you get,
Excuse me. Hello. I'm ready to start. You done? Now, if you look at this problem, this is something that you've seen. Could someone raise their hand and share with us what property would we have to use in order to get the x term out of the parentheses, Lauren? Distributive. So what is our Julie? Remember we talked about Julie? Distributing Julie and her dating history. So Bree, what are we going to distribute? Yep, we're gonna take this factor of 4 and distribute to each of the terms inside. So what would we have once we distribute 4 to a 7 and 4 to a negative 3x? What would be our two new terms here? Could someone share with us? Greta?
28, negative 12.
All right, so we got negative 12x. And has this been affected at all? Nope, so we're going to bring our inequality down. And doesn't this look like something you did last night?
Yeah.
From here, I'd like you to solve for our x. Would someone like to share with us before we continue, or you continue? Remember how we talked about this yesterday, how to tell if you're going to flip or not. Does anybody know if we're going to flip?
Yeah.
Right now, before you even start?
Yeah.
Okay, all right. Is it getting easier to identify that?
Yeah.
All right.
I just
The more practice you have, the better off you're going to be, guys. And this is going to should be easier and easier every day. That's what I'm hoping.
I actually like some of these programs.
I hope you like them because you're going to be doing a heck of a lot more than what I show you this year. So it's just going to get more, algebraic. I mean, think about it. You're going to take Algebra 1 next year, so it's just going to be more algebraic equations and inequalities. So we got negative 12x is less than negative 48. Do you all agree with that?
Yeah. No. Oh, yeah.
All right. You all right?
No.
Okay. I'll slow down.
No. Like, okay.
Keep going.
No, I'm there.
Oh, okay. All right, then, to get rid of multiplication, we use what operation?
Division.
Division. So then we're going to obviously make that x. And when I bring this down, what does less than or equal to turn into? Lindsay?
Greater than or equal to?
Yes. Because this negative sign right here also changes that to its opposite. So we have what? Positive 4. So x is greater than or equal to, positive 4. So when I graph this, we have 4, a 3, and a 5. Let me handle this. And we have an open or closed dot. Close. And is the arrow going in the right or left, Sydney? Mm-hmm. Did you flip it? Did you forget to flip?
I forgot the negative on the movie, so I see it.
All right, so because remember, we're putting a negative 20 here, and we have negative 20 here, and we have negative 28 there. So we have to make sure that you obviously put those, we're staying in the negative, we're same signs. So we're going to add them. All right, so are we done?
No.
No, we're not. So we have to go back and check. So we have 4 times 7 minus 3 times, what would you like to plug in? Who would like to suggest something for us? Let's see. Somebody I haven't heard. Cabernet, I haven't heard from you yet today.
4.
4? You guys, we can use 4? We good with that?
Yeah.
Is equal to? Yeah, we can include 4 into our set of numbers that are, and then is less than negative 20. So obviously, in order of operations, you notice that we now have grouping symbols. So we actually have to make sure that once we have our grouping symbols, we have to get that down to 1. So we have 4 times 7 minus, what's 3 times 4? 12. And then we have 7 minus 12 is?
Negative 5.
Negative 5. And is negative 20 less than negative 20? Or equal to, sorry, less than or equal to. Thank you.
Yep.
Are we good? That's true. So we can move on. All right, here we go. Let's distribute a fraction. Can anybody remind us how to distribute a fraction? Since we haven't done that in a while. Noah, could you explain it to the class?
You multiply the numerator by the number, and then you divide it by the denominator.
Yep. So in this case, the numerator of 1/2, does 1 change anything?
Nope.
No, so all you're doing is, the only thing that's going to change is the dividing by 2. Would someone like to share with us? Once you distribute that 1/2, what does 10h and negative 6 turn into?
5h.
Okay, so we're going to distribute this. Harrison, what do we got?
5h and, wait, negative 3.
There you go. And again, aren't we right back to something that you had yesterday? All right, so let's continue there. What would you do first? What operation? Let's do this quickly together. Alec, what would you do first?
You would add 3.
All right, so we're going to add 3 to both sides. Does that flip the symbol?
No.
No, it does not. What only 2 operations flip the symbol?
Multiplying and dividing by negatives.
There you go, multiplying and dividing by a negative number. So what do we got? We got negative 23 plus 3. What's our new constant over here? What's our value on the right-hand side there? Caleb?
Negative 20.
There you go. And what's our last operation or property we're going to use to solve there, Garrett?
Divide 5 on both sides.
Yep, divide by 5, because that turns that h into 1h, and ultimately that's our goal. We want to find what 1h's value can be. All right, 1h obviously has more than one value it can be because it's an inequality. But we have 1h. Are we flipping?
No.
No, we're not. Keeping it the same, because this is a positive 5. We don't need to do anything. But this time, there you go, Sydney. Now you have your negative 4. All right. So now we have to graph our solution. We got negative 4. What's on the left side of negative 4? What number?
5.
Negative 5 and negative 3. All right. Open or close dot?
Open.
Open. Are you sure?
Yeah.
All right. Open. And the arrow's going into what direction? Left or right?
Right.
To the right. Nice. La, 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 la. There we go. And now finally, we go back and check. This time, can we actually use negative 4?
No.
No, we cannot. There's no equal to, so we have to make sure that we pick another number. So let's do this. We have 1/2, and we have 10, and we're going to plug in an h value. What h value do you want, Lindsay?
0.
0? Can you imagine 0 that way?
Yeah.
All right, so we're going to plug 0 in, and it has to be greater than 23. So we got 1/2. We have 0 and negative 6 left. What does 0 and negative 6 make? Negative 6. And what's half of negative 6? If you split negative 6 in half, Anna, what do you get?
-3.
Nice. Very nice. And is that a true statement? Is that a true inequality?
No.
Yeah.
Negative 3?
It's negative 23.
Well, that would help. That would help us all, wouldn't it?
Yeah.
All right, so we got to make sure that Mrs. Alms writes her checks right. Just like you make mistakes, it's a perfect example. You forget one sign. Do you guys see how that didn't match?
Yeah.
That wasn't right. So we need to go back. Did I write this right? Oh, did you guys see? You guys are getting better at finding my mistakes when I make them. Okay, so I want you guys to get good at finding your mistakes too, if that's the case. All right. Obviously we don't try to make mistakes on purpose, but that's what obviously that's over 15 years. That's what I do the best at is when I look at your paper, I'm trying to find mistakes. All right, and that's what I do. But for you guys, I know you guys don't want to make mistakes, but it's going to happen, and that's where, you guys figured it out very quickly what I did wrong. Okay, because you could look at your work versus my work, and that's what you did. Okay, you love pointing what I do wrong out very quickly. You're not shy about it, are you?
Nope.
Not at all. That's fine. Because I'm not shy either, am I?
No.
Nope. I'm not going to go there. All right. Now we're going to start off with one of these. I actually never had you guys solve an equation that looked like this, but I think you can do it. And they're out there. I actually saw Mrs. Cook and Mrs. Nelson upstairs in the copy machine, and they had worksheets and they had these all over it. So I'm like, you know what? I'm going to just give them a couple of them. Now, I'm not saying they're going to show up on a quiz, maybe an extra credit, never know. But I think you can do it. The first thing is as you look at this one looks a little different. All right? You guys agree that the left-hand side, you guys see the fraction?
Yeah.
You have a numerator of x plus -4 and a denominator of 7. All right? So whenever I saw these, when I was a student, what I used to do was when I looked at these problems, I said, you know what? I can't divide two terms at once. Do you know how to do that?
No.
No. So what I thought was this. What you have to do is let's pretend that there's parentheses on the top. All right? That might help us. All right? So the first thing when you see this is that you have to get we're trying to get this out of a fraction mode. So if you notice, does anybody have an idea how we could get just the top by itself? Because isn't that where the x is? Just like remember how the x was inside the parentheses, we use the distributive property? But do you see anything that we could do maybe just to get that top part? I just want it by itself. Meg?
You could solve it pretty much on the top part. So add x to -4.
You can't do that because x, we don't know what x is yet. If we knew what x was, that would be easy. All right?
So wouldn't it be -4x?
No, you can't put these two terms. They're not like terms. An x and -4, that's a constant, and that's a variable term raised to the first power. Okay, you can't put those two terms together. So you're stuck at this point. So you got to get x out of the numerator. You got to get this right here, what I put in parentheses, by itself. Anybody have an idea? Bailey? Can't add 4 to each side. Bien?
Subtract 7.
Nope. I wouldn't. Think about what operation is 7. What are you doing? Division. How would you get rid of that? What would you do? Think about it. If I multiply this side by 7, what goes bye-bye? The denominator. Now did we just get rid of the fraction?
Yes.
That's what you want to do in these. You want to get, we like fractions?
No.
So we got to get rid of it. So we're going to multiply this by 7. So this cancels this. And what do we have left on this side? There it is. Do we have just the numerator now? Do we have a fraction anymore?
No.
Yay! Isn't that nice?
Yes.
And what's -8 times a 7?
-56.
-56. Now, do you know how to solve
Yeah.
a problem like this?
Yeah.
You see? One step. All it took to get to something that you already know how to do. Yeah.
For like the thing that was in the parentheses, can you just take the addition sign out? Or is that the same?
Yeah, whoever's humming, stop because you're distracting me. Absolutely. Anna wants to know if she can just write this part like that. Is that the same thing as adding a negative? Is the same thing as subtracting a positive? Same thing. Perfect. Garrett?
Could you add a 4/7 to each side?
No.
What?
Okay.
Nope. Noah?
Wouldn't that be 7x then? If you multiplied x by 7?
No, because you're dividing by 7. You're dividing by 7. You're getting rid of the dividing by 7. So if you multiply by 7, you're undoing this right here. Dividing by 7. If you multiply by 7, what's 7 divided by 7? 1. So now you have 1 times this. What's 1 times anything? Itself. So that's why you get whatever's in the parentheses. Okay?
Subtraction just multiplied by the denominator.
Yep. To get rid of the fraction. But it makes sense to put it around the parentheses so that you don't get mixed up that you're not going to distribute or anything. All right. So now from here, I'm going to add 4. I'm going to add 4 here. So hopefully you got x is greater than negative 52 is right. And then we have negative 52, negative 53, negative 51. You guys okay with that?
Yeah.
Yes.
Okay, is open or closed? Arrow's going to what direction? To the right. Okay, so now we have to check it. So Harrison, what is, you're all up in arms here, so go ahead.
Negative 10 for x.
You could.
I use 0.
No, if you did 0, it would be 4 sevenths.
Yeah.
Negative 4 sevenths.
Negative 4 sevenths is between negative 1 and 1. I believe that's closer to 0 than negative 8 is.
True, but like, oh yeah.
Isn't that a fraction less than 1? It's less than negative 1.
I guess you could do that. I was just saying,
But so then it's between 0 and negative 1.
I'm just saying, like, you solve it faster if you want, like, the actual number instead of a fraction.
Sure, you can do that. If you want to do 10, if you want to do negative 10 plus negative 14, why did he pick negative 10? Well, when you put these two together, are they divisible by 7?
Yeah.
Yeah, sure, absolutely. If that's what you want to do, that's great. So we have negative 14 has to be less than, divided by 7 is has to be greater than negative 8. So we got what? Negative 14 divided by 7. And what's that going to be? Negative 2. Is negative 2 closer to 0 than negative 8 is?
Yes.
Yes, it is. So it's greater. That's good. All right, let's try one more of those. Let's see if you can do it. Oh, come on. Let's change that. All right. Oh, I forgot. Oh, I forgot my other number. What do I want? Yeah, I have to write it in. All right, let's do this.
23.
5.
All right, the first thing I want you to do is put a parentheses around that problem right there. So how are we going to get it out of the fraction look? How are we going to make it just become the numerator? Okay? Remember, anytime you want to get rid of a denominator, you just multiply by it. Okay? Lauren, what are we going to do? Yep, we're going to multiply each side by 5. So I'm going to multiply this by 5. That gets rid of this. Remember, isn't 5 on the top? Look up here. When you multiply by 5 over here, this 5 is in the top, this 5 is in the bottom. When you have 5 in the top and 5 at the bottom, don't they cancel each other out? That's what you're doing. You're trying to get rid of that 5 because you just want x, in the top so that you can solve for it. But if you multiply by 5 there, you got to multiply by 5 over there. And then, what do you got?
Negative 70.
Negative 70 is greater than or equal to x and negative 3, because those 5s do indeed cancel. From here, what do we got? We're going to do what? We're going to do to both sides to get x by itself. Talon?
Add 3 to each side.
Yes, nice. So we're going to add 3 to each side. So right now we have x is less than or equal to what? Negative 67. Emma, you good with that? All right. So we're gonna. How many of you rewrite this? Anybody do that? Okay, it's fine if you do. If you did, you should have remember the little point is facing the x. So if you rewrite it, make sure that you rewrite it with that little point still facing the x. All right. So x is really less than negative 67. So we have to graph this. We have negative 67. What's right here?
Negative 68.
All right, negative 68. Ooh, forgot my, look at that. And negative 66. Open or close that on that negative 67? Mm-hmm. We're closing it up. And which direction are we headed? To the left. All right, now you gotta make your brain work a little bit. What are we gonna plug in for x this time? Bree, what did you plug in, hon?
I plugged in negative 67.
Yes, so did I.
You did.
Yeah. I did
And why did you do that?
because negative 67 plus negative 3 makes negative 7, which is
Negative 70, you mean?
yeah.
Uh-huh.
Which is divisible by 5.
Yeah. So you want to make sure that you pick a number that you plug in for x that this time is divisible by 5. Absolutely. Because is 0 possible this time?
No.
No, since the arrow's going in the opposite direction of then 0 is, we can't head to 0 and pick 0. We gotta go the opposite way. So, we got negative 14 less than or equal to, we got what, negative, you said negative 67?
Yeah.
And we got negative 70 up top over 5 has to stay less than negative 14. And when you guys plug that negative 67 in, what'd you get?
Yeah.
And that's true, isn't it? Because that equal sign is there. All right. Now, is there any questions? You guys want to do one more off your homework?
No.
Oh, you're good?
Yeah, put these on the test. Oh, the quiz.
I might.
Yay.
You never know. Maybe. Maybe. You never know.
That's cool.
All right, let's go over what problems I'm going to pick, and then I'll stop the video. So just in case you forget, you can go back and watch it. All right. Let's do this.
Wait, your homework.
The homework off of this, off the problems that we didn't choose yesterday, same worksheet, you should have it still. Out of the 8 problems I assigned and corrected today, we'll just continue. Huh? Why? You're on candid camera? You gonna like tell me that? All right, we're gonna try 3 and 4.
So 3.
Number 6. Number 12. Flip it over.
18.
Number 13.
15.
And number 18. Number 21. What am I up to? 6? That's up.
24.
No, that's no.
That's 7. That's 7.
And then you're going to do number 24.
Yay.
Oh gosh.
It's not even that much
I
homework.
don't like homework.
It's 8 problems.
I got that we get.